guys, Alex Peak Performance Reviews. Welcome to another vlog, and yeah, welcome to another PPR Tech Garage. So another episode, and today's video is going to be all about car battery and the fundamentals of what a car battery does, and yeah, so you can kind of learn a bit more about car batteries. Sounds quite boring, but at the end of the day, if you've clicked on here and you are interested in learning, then yeah, stick around and watch the video, because you will learn something probably new. Some of it's probably like, well, you know, is it boring? But at the end of the day, it's worth learning these things and understanding more about your car and you know, what those bits do. So first and foremost, first thing that a car battery does is obviously it's there to start the motor, there to start the car up. Obviously you go for the key and you turn the ignition fires, and it basically, this battery is there to crank over the engine and start the car. And thereafter that process, the next thing and fundamental that needs to do is it needs to power all of the ancillary equipment, things like lights, sat navs, alarm, stereo, all of those things that does. And then thereafter, while that's done what it's needed to do, the next thing that happens is the alternator recharges the battery. There's different types of batteries. Obviously, most batteries are lead-based batteries, certainly the ones that you buy off the shelf that are relatively cheap. And these batteries used to be either available in an open type battery or a sealed. Most batteries are sealed now, and some of the old batteries used to have open cells where you could top up the battery. It's not much of a done thing anymore, so they are sealed batteries. Most batteries are sealed. Going on to the battery, you have two posts, a positive post and a negative post. You'll see a positive sign on one side and a negative on another side. Ours is this way positive and that way negative. Depending on what your car, how the orientation of where your car battery is and where the leads go to the top of the post, that will dictate what battery you require. This is an S4004. There's some really good websites out there that will, if you put your car registration in, they'll tell you what battery you need, what type of battery you need. Normally, the difference between battery and battery will be the width, the height, and typically the amps, which is kind of typically the cold cranking amps, the CCA, which is the cranking ability and how much kind of force and amps required to crank over that size engine. Normally, the smaller the engine, the less inertia required to get it started, to get it cranked over. If you've got big, heavy crankshaft and pistons, like in my Supra, for example, a big heavy 2JZ with a heavy crankshaft and pistons, it will require probably quite a high cold cranking amps. A lot of normal batteries don't give a CCA, but on specifications and on further looking into this, you can find out the specifications of cold cranking amps and a typical amps readout. There's also amps and hours, which is the charging rate, typical charging rate, and at the voltage. All car batteries, or most car batteries, are going to be 12 volts. Going on to that a little bit further, batteries have 6 cells internally, and I'm going to try and give you a VT rolling while I'm talking this through. But these batteries have 6 separated cells within the confines of this battery. This is obviously sealed, but it's got 6 compartments, 6 cells. Each cell is 2.1 volt, which makes 12.6 volts in total. Each compartment and cell has rows of plates in them, and they are either positive plates or negative plates. There's 8 positive plates and 8 negative plates. The positive plates are called lead dioxide, and the negative plates are a lead sponge. And within the surface of all of those plates within this battery, essentially the bigger the surface area, the more amps and energy potential of this battery. So normally the bigger, the higher the ampage, as simple as that. And that's why actually on some commercial vehicles and probably things like tractors, there'll be some really big, huge batteries that are required on things like that, because they need a real big cranking amps to turn them over. The positive plates carry electrons and the negative plates release electrons. And inside that battery there is a solution called electrolytes. Within the electrolytes, they're kind of the solution of electrolytes are made up of sulfuric acid and water, 35% of which is sulfuric acid, and typically 65% of water. That can be a little bit of a different solution, but very similar to that amount of a solution. The point of that solution is to allow an isolation between each plate, and that works as an insulator essentially, and it allows the electrons to pass through the plates and through the solution, but isolate the plates. And essentially what it does is it allows positive and negative ions to move freely and essentially create energy within the battery. I'm not going to go into the more fundamentals of that, but that's the basics of it. I think any more than that, and it's worth maybe looking into things further, or looking into potentially other videos or other kind of things that are out there, but that is the fundamental basics, so it's worth kind of noting that. During this chemical process, excess ions flow out of the positive plates, out of the side of the battery, and then they go through the electrical component which is required, so headlight or sat nav or stereo, whatever it will be, and then back to the positive side of the battery. And that's kind of the cycle, the chemical cycle of what happens in the process. After that, the alternator reverses this chemical process, and basically it goes round and round and round in a cycle. And that is as long as the engine is on, because the alternator is allowing this process to happen by recharging the battery. So basically, as the ancillary pulley is moving around and rotating, the alternator is working, and it's distributing the energy back into the battery, so through the alternator and back through the battery, and it's allowing the battery to keep at a energized chemical state. So it has stored energy ready for any ancillaries and any ignition processes being happening within the car at that time. Obviously, the other thing that the battery will do is the moment the car is turned off, the alternator is then not working anymore. So if you leave the lights and the sat nav on, the stereo, all that time while you've got those lights and all them ancillary equipment on, and the alternator is not recharging, what happens is the energy from the battery just gets used and depletes and gets used, and it just continues to deplete until potentially the battery is dead completely. If the battery is dead or it's quite low, chances are that it's got quite a low cranking ability. So you'll try and crank over the car, you'll hear the starter motor tick, 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 ticking, but it won't fire and the car won't fire up. And that will be because the energy of the battery is too depleted. That's normally if you've left it for a long period of time. This obviously has the ability, and that's why it's normally sized specifically, to allow, quite some, use of the lights being on for a long period of time, plus the stereo on for quite a time before it would deplete to a point of where you will go to start the car back up and it won't start up. So rest assured, you can leave things on for quite a while, but if you leave them on for too long and then you go to restart the car, the chances are it may not start back up. So obviously you need to kind of crank that back over. Actually, while we're in this pandemic at the moment, actually it's quite apparent to let people know about battery life and battery health. Obviously, if your alternator is not recharging the battery at this state and you're not going out to your car and restarting it, chances are the battery is just depleting, because most cars fundamentally have some form of ancillary drain, power drain, on a battery, and normally that's in the form of an alarm. So the alarm will take a draw of energy, and slowly but surely, but quite slowly, it will be taking a draw and it will be depleting that battery. So chances are, if you're not starting your car up, starting it over, it's a bit like leaving oil. It gets old. The electrolytes also within this battery will get old and tired, and they won't work as well as they did when it was new, or whether it's been operated in the right way and continued to charge, recharge, and have this chemical process happening. So if that's not done, you can get a battery that will start to deplete and discharge, they call it. And it will basically die. It will die a death, or it won't crank over the car as well anymore, even when you recharge it. So you either need to trickle charge it and make a good habit of trickle charging it, or you can buy a proper good quality trickle charger. And I'll probably put some links in the bio as to where you can get some of those, but they're really good. If you are a lot of classic car owners that I know that don't run their cars over winter, they buy these little special trickle chargers, not ones that you typically just put on and you trickle charge manually. They will self turn off and turn on as it depletes at a state of where it feels it needs to. Very clever, but yeah, very clever little trickle charger. You can buy those, and they're really worth buying. I think these little C-Tech chargers are really good, and I'll give you a link in the bio of some of the ones that we recommend. If you're running a classic car or a little track car or a race car, you want to try and reduce the weight on the car, and that's something I'm going to go into in another PPR Tech Garage video very shortly, is how lowering mass on a car can affect the car's handling and performance characteristics. And obviously in my little race car, I've used a couple of different batteries from Hawk Motorsport that use a Li-Fi battery or a lithium ion battery. Very small batteries, so they take a lot less space. You can sometimes mount them lower for a lower centre of gravity, another positive I'll go on to in another PPR Tech Garage. But also you can reduce the weight by a huge amount. My race battery on my Supra and on my Civic was about 3 kilograms, and 3 kilograms versus 15 kg of weight is a good weight removal, but it still had the cold cranking amps of a battery that was 15 kilograms. So there's some huge benefits. Obviously, these clever batteries are, and more modern batteries are, a lot more money, but you've got to work out the power to kind of pounds ratio of what that can do for you, and then decide whether it's right for you. But I'm going to go into that another day. There's lots of more fancy technology which typically costs a lot more money in batteries these days. But anyway, that is the fundamentals of a battery and how it operates and what it does within your car. And I hope you enjoyed that PPR Tech Garage. If you've got any comments for us, hit us up in the comment sections, because we always like to hear what your thoughts are and any comments really in general. And yeah, I hope you enjoyed. As always, like, share, comment, subscribe, and we'll see you again in the next one. Bye for now.